So I'm Grant Ellington. With the Biological and Agricultural Engineering Department at NC State. I wanted to give you a little overview of a project we've been involved in for the last 2 seasons. But this work involves myself, Kyle Boston, and Justin Michelik, who are also in the Bio and Ag Engineering Department at NC State. And the title of this project is Turning Vane Assessment to Improve the Air Handling Efficiency of Bulk Curing Barns. Just to give you a little background information first, and then define an objective. So turning vanes are used in air handling system ductwork to smoothly and gradually reorient the airflow direction. So if you think about it, a typical bulk barn, you've got the fan and the air travels straight down. It has to hit the concrete floor and then it has to turn 90 degrees. So typically when there's a 90-degree change in direction in the ductwork, that is where turning vanes are installed. This is commonly used in HVAC applications in the industry. So it's not a new concept. It's certainly been around for a number of years. And that's exactly what we have in a curing barn. We've got that air that's has to make an abrupt 90-degree change in direction. And what happens is that generates a lot of turbulence and there's a lot of resistance there, and it certainly can take away some of the air that could be available to actually go through the tobacco. So turning vanes, and you'll see some pictures of this here as we move along, but turning vanes are manufactured from sheet metal and then it's formed in some desired geometry. Typically it's rolled into some radius dimension. And once again, the turning vane, the desired effect, the turning vane is used to decrease the duct airflow resistance and turbulence, therefore making more air available and making the airflow more uniform across that ductwork, in this case, the lower air plenum in a bulk barn. So the overall objective here is to quantify the potential energy savings and decrease curing time associated with adding a turning vane in the lower air plenum of a bulk curing barn. Decreased curing time is going to decrease electrical energy consumption, but also it's going to decrease, or potentially certainly could decrease, the LP gas consumption, although you are in stem drying phase toward the tail end, where there may not be a lot of gas consumption anyway. Probably just as important is the potential to reducing the curing time improves the harvest and management, is going to increase the throughput capacity per barn. So there are a number of variables that affect the airflow, the barn design, and when we say the barn design, the lower and upper plenum designs, and what is the height, the geometry of those plenums, the intake and exhaust vent size, that's the intake vent on the back of the barn, the exhaust vent size on the front. Typically, that's not too much of an issue in most curing barns. Structural air leaks certainly could vary tremendously from one farm location to another. Fan specifications, that is the number of blades, the blade geometry, or referred to as pitch. What kind of angle is on that blade geometry? How is the angle of the blade geometry itself? The motor horsepower on the fan, and also the rotational speed the motor's operating at. As far as leaf loading characteristics, what we're referring to here is the leaf orientation and also the container bulk density. And most of the containers we're referring to are going to be the large curing boxes, although we still do have a lot of rack barns. But the container bulk density will be how many pounds are loaded per cubic foot of volume of those boxes. That certainly will have a major effect on airflow. So project was initiated in 2018 as far as turning vane performance assessment. We installed turning vanes at multiple on-farm locations. It consisted of Wilson, Johnston, and Sampson County. So at a given location, what we're doing is taking two identical make barns. These operations are large enough that they're going to typically load multiple barns a day. So they would load these two barns simultaneously or concurrently. The same pounds of tobacco, the same type of tobacco, typically coming from the same field, so sort of minimize those variables. And then we've got one barn that has a turning vane installed and the identical make barn beside it does not. And some of the performance information we're collecting is between the barn with a turning vane and the barn without will be the total energy consumption. That would be fuel, LP gas, and electricity. So we'll monitor fuel and kilowatt hours of energy use. Static pressure, which is an indirect way to measure airflow. And we'll monitor this continuously during the curing process, the cure duration, how long is the cure, and temperature profiles. And so we're getting a spatial temperature profile on the barn, the lower air plenum and the upper air plenum. We actually expanded that moving into this season to get 6 temperature read, 3 in the lower air plenum and 3 in the upper air plenum on both barns at a given location. And certainly we utilize grower feedback to determine if there's any, or certainly assess any cured leaf differences associated with a barn with and without. You certainly would anticipate there's probably not going to be any, but nonetheless, we still rely on grower feedback. This is showing the bulk curing barn, just a side profile or a profile view. So you can see the lower air plenum, the upper air plenum. And you also notice it shows the lower plenum height, and it has a range of 14 to 22 inches typical. So I could go to different make and model barns at various locations throughout North Carolina, and we would see a typical lower plenum height would range from 14 to 22 inches. The lower it is, typically you would see a little more resistance to airflow. So typically the lower plenum height is, the less resistance to airflow it's going to have. And so this is showing what a turning vane looks like, and it is simple sheet metal structures that are added to, instead of having that 90-degree abrupt change, now we can gradually have that airflow change directions. And so addition of turning vanes is going to improve the ductwork airflow, once again uniformity, and it does this by reducing the resistance and turbulence associated with if you did not have a turning vane in the ductwork. And once again, this is a very common application in the HVAC industry. This slide is showing just a couple of pictures of our turning vane geometry. And so the picture on the right is showing the actual 16 gauge sheet metal that we rolled into a radius of 54 inches. And then the picture on the left is showing it installed. This just happens to be at this particular location, the Taylor barn. And so the other thing we have to keep in mind is a lot of times the grower is using this back access door that is what he uses to introduce the ordering mechanism, whatever he's using to order tobacco at the end of the curing process. So we have to be aware of that, and so that they can still get their ordering mechanism into the barn even with this vane installed. So this vane will actually pivot up the way it's hinged, and it's mounted to the existing frame on the barn, and makes it certainly a lot easier for the grower to add their existing ordering equipment. Here's the Johnston County location, just showing 2 barns, 2 identical make barns. One has the turning vane installed, the adjacent barn does not. Some of the data acquisition, a manometer to monitor continuously static pressure, temperature profile, data acquisition equipment, and then the picture on the right is showing a kilowatt hour meter. And obviously we have LP gas meters installed on both these barns too. And this data acquisition equipment is certainly installed for both barns. So a little bit about the results to date. So we had a limited number of cures evaluated in 2018 and 2019, and certainly a couple of reasons why. Adverse weather. We've had certainly some tropical systems in that time. Contract reductions in barn loading schedules. So as a result of the contract reductions, the barns are not as loaded as frequently, or they may not be loaded as consistently, certainly. But the bottom line is there's a reduced number of cures, and that's been typical over the last 2 years. But what we have seen is growers at a couple of locations have noticed a 12 to 24 hour time savings. But that's not easy to quantify because the grower, we have to know exactly when the grower stops the fan motor. In some cases they may not, they just realize one barn's cured out by looking at something else. And we've got to have a better way to timestamp that. And so that's what we did last year. We incorporated a way for the grower, when they thought it was done, to simply click this button, and that would timestamp us that the fan was stopped comparing the two barns. Evaluation is going to continue this season at 4 locations. We added a location, and the additional location was added because the growers had commented. We were already at this farm doing the heat recovery evaluation, and the grower had commented that they were having some problems with the front boxes drying out and a couple of barn makes. And we said that one thing we may could do is add a turning vane, and that would be a real quick way to evaluate the effectiveness of it. So that's why we added this location. We simply went in now and implemented all the data acquisition equipment I just showed you. Plus, we've now added a turning vane in one of those barns, and the barn directly beside it does not have one. One thing at the Wilson County location in 2019, it was averaged over 3 cures, which is not a lot of cures, but we averaged about 16 hours decrease in curing time. But just as importantly, a comment from the grower was that he was noticing consistently less swell stems in the barn front box compared to all the other barns, the identical make barns, that did not have one. And so the benefit of that is, which we certainly had not given a lot of consideration to, was the time and labor savings associated with less market preparation, when you don't have to spend as much time picking out any swell stems, or certainly reduce quality tobacco. And this certainly would like to acknowledge, this may not work on all barns. Some barns, the range of existing lower plenum heights is 14 to 22 inches. The lower plenum accessibility. Some barns, a lot of barns don't have a back access door, and so there's not an easy way to get underneath the fan without pulling up the floor, certainly taking a lot more time to actually install a turning vane. So the barns we're using strategically, we picked those because we've got very easy access to get into the back of the barn. Also, it may interrupt their ordering process. There's some ordering mechanisms growers use that this may get in the way and be a problem. Tube axial fan versus centrifugal fan configuration. Most of the 10-box barn type barns use tube axial fan configurations, or the big prop fans. But barns with centrifugal fans, the housing of the fan itself is already, the geometry of the fan is already delivering the air into the lower air plenum at a 90-degree angle. So it certainly may not work as well in a barn that has a centrifugal fan configuration. But the bottom line is, this is a relatively inexpensive technology to manufacture, and growers certainly can implement this without any third-party assistance. And when I say relatively inexpensive, certainly we're talking about less than $100 to take a piece of sheet metal and roll it into some desired geometry. So certainly moving forward, we've got this season coming up to collect information, our 4 sites with the additional site we've added for 2020. So more to come. But lastly, I certainly would like to acknowledge our funding entities. That's the North Carolina Tobacco Research Commission, Japan Tobacco International, and then our own farm cooperators, Triple B Farms in Johnston County, Vic Farms in Wilson County, Warren Farming in Sampson County, and the last one is Drake Farms in Edgecombe County.